Good morning, welcome to Physics with Keith.
Good morning, welcome to Physics with Keith.
Turn off my
Good morning,
sound.
welcome to Physics with Keith.
There we go, that's annoying. Right, good morning, welcome to Physics with Keith. It's Saturday the 15th of August at 10 o'clock in the morning, so it's time for our physics tutorial. This was week 4, which is about waves and optics. This is a reminder, this is a live tutorial, so if you are out there watching this and you want to comment while the video is going along, ask for help, ask me to clarify something on something I've explained, or ask some more questions, or even give some answers, then you can do so by going onto YouTube and using the chat feature, which is on the right here. So you'll type something into the little chat bar here, and I will then see that. So I'll just type the word "Hello World," and off it goes. And I'll have that open throughout the entirety of today's tutorial. So if you have got any questions, please do ask. Even if they're questions about previous weeks, doesn't matter. I can talk about those as well. Now I looked at the Isaac Physics progress yesterday evening at about 6 o'clock, and not a lot of progress was made. In fact, nobody. 11 people have signed up for the course, 0 people had done anything towards it. Now I'm a teacher, so I can't sit here and then say, well, yes, everything will be okay. If you've signed up for a course but you're not doing the course, you're not benefiting from the course. That's the way it is. And I know there's a situation where a lot of year 11s are getting quite nervous about their GCSE grades coming out, and they may want to sit the exams in the autumn term. Are they going to be doing the exams? If they are, then they need to be doing some work towards them, and many schools won't be able to offer any support for that. This would have been a perfect opportunity, but as I say, it doesn't look like anyone's taking it up. So I'm feeling pretty demoralised by the whole thing right now. I've got a little message here from Lex saying hello. That's at least one person. I would say that makes it all worthwhile, one person out there. But I didn't check to see if any more Isaac Physics progress had been done since yesterday, because as I said, I was feeling thoroughly miserable and fed up about it all. So let's go through some of these questions, and maybe that's going to help some people. Maybe not. We'll see. The questions we were looking at were these questions on waves and optics. There weren't so many of them, but some of them were going to take a bit of time to get the answers for, because you had to draw some diagrams. And I'll help you out as much as I can drawing those diagrams. Yes, Lex said he completed it this morning. That's super. So if you do have any questions about it, do let me know. Drop a little message and let me know. So let's have a little look starting from the beginning, shall we? Frequency. So ultrasound pulses a wavelength of that, and the speed in water is that. What's the frequency and what's the time period? Let's just take a little screenshot of this so I can doodle on it. And scroll. Right, that should be. Scroll a little bit more. Where's my mouse cursor gone? Downside of having 2 screens. A little bit more. That'll do. Okay, so first of all, we need to get this wavelength in units that are sensible. Although we can work in these units, it's not going to be easy. We'll have to do a conversion at the end. It's easier to convert the units at the beginning. So we have a wavelength. Oh, come on, handwriting. What's going on with this? A wavelength, that'll do, of 1 millimeter, which is 1.0 times 10 to the negative 3. This looks like my tablet has been set up. Yes, the screen is calibrated wrong on my tablet. How frustrating. Never mind, I'll go with it. Everything's going to be a bit stretched today because I'm not going to mess around calibrating it now. So wavelength is 1 times 10 to the negative 3 meters. Fine, we've got the speed of the wave, which is 1,400 meters per second, and we are asked for the frequency, and the equation we're going to need is the wave speed c equals f lambda, rearranged so that frequency is the subject. So that's frequency equals, divide through by wavelength, c over lambda, and substitute our numbers. 1,400 divided by 1.0 times 10 to the negative 3. Take out a calculator. 1400, enter 1e3 minus, divide, and we get 1.4 times 10 to the power of 6 hertz. So that's 1.4 megahertz. 4 megahertz. So the message comes through. So let's have a look and see if this is somebody on the Facebook Messenger. No, that's just YouTube telling me that I'm live. Yes, I know that. Okay, so let's plug that into the website and see if that worked. 1.4 megahertz. Website is here. Is megahertz an option? Well, hertz is an option, so I'll just have to put 1.4 E6 in there. Correct, of course it is. And then time period. Time period is the reciprocal of the frequency. So if you've got one of those awful Casios that seem to be so popular at the moment, they've definitely cornered the market and convinced people that they're worth having. They have a button on them that says either 1 divided by x or x to the power of negative 1. If you've already got the answer on your calculator, you can just press that button and then press equals. If you've got a reverse Polish notation calculator like mine, it's one fewer key press. I just press that button and it gives me the time period, the reciprocal of the frequency. So time period, which is 1 over frequency, which is 1 divided by 1.4 times 10 to the times 10 to the 6 hertz equals, and then we write down our 7.14. I'll leave it at 7.1. I'll leave it at two significant figures, times 10 to the negative 7 seconds. Okay, so that's about 710 nanoseconds. Let's go and see what it says on the Isaac Physics website. Time period of the sound. Well, we've got to do it in seconds. So let's just flip across again. Check I've got the number right. 7.1 times 10 to the negative 7. 7.1 e minus 7. Check my answer. Correct. Okay, so that was the basic equations. Next says, after I've gone through the first question, which I've just finished, could you run through the final question? I really struggle on that one, thank you. Yes, of course, let's go straight to that final question. So if I go back to the game board, the final question, which is 48.1. 48.1 is the question with all these lenses in it. And it's got situations where the distance to the object is twice the focal length, or the distance to the object is between once and twice, and so on and so on. And lenses used to be included only in the IGCSE. I think it was the Cambridge IGCSE. It didn't used to be in the EdXL IGCSE, and it wasn't in the other GCSEs. Since the GCSEs changed a few years back, it's now been included in regular GCSEs as well. So depending on your school, you may be in a school that doesn't actually have the notes or resources for the regular GCSE, for the new GCSE, if they're still using legacy resources. So let's just draw our diagrams. Copy and complete the ray diagrams by following the path, blah 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 blah. State whether the image formed is real or virtual. And so here's our picture. And we know that this object here is twice the distance from the lens as the focal length. And that's all the information we are given. So let's draw our diagram. Let's just give myself a blank piece of paper. The first thing I'm going to draw is the principal axis, which I will draw down the middle of this page. Like this, principal axis. And I'm going to use this squared paper because it's going to make it a little bit easier. And in fact, I'm going to put snap to grid on because that might help me with my drawing. Although on OneNote, snap to grid is temperamental. So hopefully you can see that. That's my principal axis down the middle. Now I'm going to draw my lens. And I'll just check what kind of lens this is before I start. This looks to me like a convex lens. Does it say? Copy and complete ray diagram, throw in the path, blah blah blah. It doesn't even say, but the diagram makes that look like a convex lens. So let's go with that. So I'm going to draw that right in the middle. I'm going to use the usual convex lens diagram of sort of, I don't know what you call it, notation perhaps, of drawing two arrows pointing away, indicating a convex lens. Remember, a concave lens, you would draw the arrows like this, to indicate this is a concave lens. I'm not going to do that because it's not concave. This is a convex lens, and so I'm going to draw the arrows, which is really tricky to do when my whiteboard is incorrectly calibrated. Not sure why it recalibrated itself. Come on, you can do this. That's better. Okay, something a bit like that. Now we need to mark off some points. So let's put our focal point on each side of the lens. And I've chosen 2 squares for the distance to the focal points. And then in the first question, we are told that the object is twice the focal length. So the object is here. So let's draw that. And I'm going to draw my object, I'll draw it in blue, as an arrow, and I'm going to draw it 2 squares tall. I've just picked some length. Doesn't really matter. I've just picked some length. 2 squares tall. There we are. And now we need to draw our principal rays. And I'm going to use green for my principal rays. The first principal ray goes parallel to the principal axis and then refracts through the far focal point. Might have to turn snap to grid off. No, that's okay. The second principal ray goes straight through the center of the lens undeflected. So it goes through there. So what I'm doing is I'm looking here to make sure that the ray goes straight through the center undeflected. And with the first principal ray, I was making sure that the ray was parallel to the principal axis, and then it refracted through the far focal point. And already you can see that the 2 rays converge at this point here. There is a third principal ray which I will draw for completeness, but in your exams you'll only have to do 2 of the 3 principal rays, and that would go through the near focal point. I think that's moved slightly when I released it. Let's try again. As I said, snap to grid on OneNote is a little bit dodgy, and then parallel to the principal axis. There we go. So the third principal ray goes through the near focal point and then parallel to the principal axis. So those are the 3 principal rays. Parallel to the principal axis, through the far focal point, straight through the center of the lens undeflected, and then through the near focal point and parallel to the principal axis. And you'll see that all 3 of those rays converge at one point. That point is where the image is formed. And this image is the image of that top element, that top position of the object. If we were to do the same process from the middle of the object, we would get a point here, which is the middle of the image. And if we were to do it from the bottom, we would struggle because we're on the principal axis, but we know that the image would be somewhere on the principal axis. We don't have to, because we have done it for one point and we know the object is on the principal axis. We can say with confidence that the image is there. Well, again, snap to grid is being dodgy. Let's try and make sure that actually snaps. Okay. So there's the image. Well, what does the question actually ask for? We've drawn the diagram, but the question wants to know, where is the image? So let's have a look at the picture. It is twice as far away from the lens as the focal point. As the focal length. So it's at 2f, and it's on the right-hand side of the lens. Correct. What's the size of the image? Well, let's have a look. The object is 2 units high. The image is 2 units high. And because the image is inverted, we would say that the magnification is 1. If the image was upright, so the same direction as the object, we would have the magnification of -1. So this is a magnification of 1, but we could just say that the size is the same as the object. Correct. And is it upright or inverted? It is inverted. Correct. Is it real or virtual? Well, does the light actually cross here? Yes, I can see that. The light rays actually pass through that point. If I were down here somewhere, looking at this and trying to work out what's going on, and I was looking at the light rays all diverging, I would think they're diverging from that point. My simple primitive brain would think that's where the object is. It isn't there, but it's where it looks like it is. That's the image. But the light does actually pass through that point. and therefore the image could be projected onto a screen. If I placed a screen at this point here, we would see on that screen an image of the object. That's how projectors work. That's how your eyes work. So that is a real image. And so we can, oops, that's a picture of my daughter and me and my wife. Let's just go back to there. Okay, so it's a real image, correct. And now there's the next situation. And so that's how we're going to build this question on. We're going to keep working through it, but I hope that gives you some idea. We're going to use the same rules, and we're going to do it again and again and again and again until we've got those rules solidly in our head. So let's modify the diagram now. We can delete the principal rays because we're going to have to redraw them anyway. We can keep the lens where it is, and we can keep the focal points where it is, but we're going to have to move the object. So this time we're told that the u, the distance to the object, is between f, the focal length, and 2f, twice the focal length. So the image is somewhere between the two. That's what that means. So you might take a bit of time to interpret that, to pick that out. But the focal length is less than the distance to the object, which is less than twice the distance to the focal point, or the focal length. And if you weren't sure what u meant, if you click on Hint and Notes on Convex Lenses, it'll tell you there what u means, although this diagram's not wonderful because it shows refraction from the first surface there rather than from the middle of the lens, and u should be measured from the middle of the lens. So I might have to let the Isaac team know they might want to change that. I don't think that's my original diagram. Anyway, let's get rid of that. So let's redraw the diagram and let's trace our principal rays. I'm just going to move it to excellent. Again, snap to grid being temperamental. It did snap to a grid, but only Akatosh knows what grid that is. So there we go. There's the object now between the focal length and twice the focal length. It's somewhere in between the two. 3 principal rays. Do you remember what they are? Principal ray number 1, parallel to the principal axis through the far focal point. Something like that. And I think I can leave snap to grid on for this. So let's just do that and try to get this to draw where I want it to. Okay, so there we are. That's the first principal ray. No different, exactly the same. The second principal ray was going to go through the center of the lens undeflected. Well, let's do that. From here, through the center of the lens, undeflected, will take us down to there. I suppose I should carry it on a little bit further, just because we're going to pretend we don't know what the answer is. So let's carry it on a little bit further. Come on. And OneNote has gone kaput, as it so often does. So I have to Alt-Tab out and back in. Honestly, software development. And now Snap to Grid has turned itself off. Let's turn it back on. There we go. I'm sure all these design choices that Microsoft made were for a good reason. Definitely, they definitely thought it through. So, okay, here we go. There's our second principal ray, and already you would be able to identify where the object, where the image is, because you can see where these rays cross. And if you were doing your GCSE exam, you could stop there. You wouldn't have to draw the third principal ray. But for completeness, I will do so. It goes through the near focal point, and you can see if you go through the near focal point, you never actually hit the lens. But that doesn't matter, because we know the lens, if it were large enough, would be here. This would be the middle of the lens. It doesn't matter. We still use the third principal ray in the same way. And then the third principal ray goes parallel to the principal axis. Okay, so you can see it's pretty clear where that point is that the principal rays all cross. They all cross at this point. Let's get my little hand out. They all cross at this little point here. That is the position of the image. So we will draw our image, and then we will go about answering those questions that we were trying to answer. And we won't even label this image and this one object, although if this was the object on the right and the rays were all travelling left, it would produce an image on the left in exactly the same place. That's a principle called the reversibility of rays. Let's draw my little arrows on there. Oh, that's a blue arrow. Let's be consistent. It's amazing how quickly the brain can adapt to a badly calibrated whiteboard. Right, so let's have a look at the image and let's see if we can answer these questions. Where's the image? Is it 2f on the right hand side of the lens? That would be here. No, it's not there. If anything, it looks like it's 3f. So let's have a look at the diagram here. 2f, is it between that and that? No. Is it beyond 2f? Yes, it's beyond 2f. That's the correct answer. Is it the same size or is it enlarged? It's enlarged. And we can see how much it's enlarged. It's double the size, so it has a magnification of 2. But this is just saying it's enlarged. Is the orientation? It is inverted. And therefore it's a positive magnification. And is it real or virtual? It is still real because the light still passes through that point. Okay, let's move on to the third one. So let's delete these. I'm going to move some things around. But I hope you can see that we did exactly the same thing. Here is exactly the same rules we followed. So let's get rid of this. And let's load this one. So U is bigger than 2F. So U is all the way over here somewhere. Bigger than 2F. All right then, let's construct our diagram. Here would be 2F. So let's put it snap to grid. So let's put it here. So U is F, U is 2F, U is bigger than 2F. 2.5F. Now let's draw our diagram. So we're going to draw our principal rays. Parallel to the principal axis and then through the far focal point. In fact, I needn't have bothered deleting that ray because it's doing it's going through exactly the same path regardless of where I place the object. If the object is height 2 units high and the focal length doesn't change, then this principal ray is going to end up following the same path each time. What colour have I chosen there? Okay. Following the same path each time through the far focal point. Second principal ray through the centre of the lens undeflected. So let's try to draw that as best as I can. Goes through the centre there to about there-ish. Let's play with our snap to grid again, see if I can get this thing to behave. Nearly get it to behave. Right, that looks like it goes from the centre there to the top there. That one doesn't look like it goes quite through the top. There we are. And so now I can identify the position of the image already. I don't need the next principal ray, but I'm going to draw it anyway because that's what I'm doing. I'm showing you how to do it all properly. So through from the top of the object through the lens. This is going to be a bit of a struggle because I'm not going to want snap to grid now. I don't think, even though I have no idea where the grid is. I think it would be the grid that's drawn on the page, but that's clearly not the case. I'm sorry, I've moaned about Microsoft far too much. Let's turn snap to grid off for this next one. And then parallel to the principal axis, which should take us through, yeah, pretty much. So the better you draw the diagram, the closer together these 3 points will be. And if you wanted to zoom in on this really closely, you'd see they don't actually quite cross in the same place. Let's see if I can zoom. Oh, I can only double it. That's all I can do. They're almost crossing in the same place, but not quite. And sometimes on your diagram it'll look really bad. It might look a bit like this. And you'll think, well, where on earth is the image then? Because I've got a cross, I've got 3 places where lines cross. It crosses here, it crosses here, and it crosses here. And what you do in that situation is you know that somewhere betwixt these 3 points is where the image forms. So you just take a place that's in between them all, and you'd use that. And that's actually the advantage of doing all 3 principal rays. It will improve the accuracy of your diagram. If you just do 2 principal rays, then you may have made a small measurement mistake or something slightly out with one of the two rays, and you'll have no idea that that's the case. By drawing that third ray, it gives you a bit more confidence that the position of the image is as you think it should be. Okay, let's zoom out again. And let's draw our arrows, just because I like them. Okay, now we've got our position of our image. Let's draw it on. It's about there-ish, isn't it? Going to there. Okay, that's close enough. That'll do. It'll do for what we're doing in this question. If this was an exam, I'd be getting rulers out and getting protractors out, or set squares to make sure this is perpendicular, this image is perpendicular to the principal axis and all that sort of thing. I don't need to do that. So what I'm going to do is just look at it and see that the object is the image is smaller than the object. I can see that it is inverted. I can see that it is between f and 2f. I can see that it is real. So let's go through and answer these questions. Where is it? It's between f and 2f to the right of the lens. It is is it diminished or invert? Or it's diminished. It's smaller. It's diminished. So I can see that the image is diminished. I can see that it is inverted, and I can see that it is real because the light does actually go there. And then we have the last one, the very last question. So what if u is less than f? In other words, what if the object is closer to the lens than the focal length? Now, hopefully I've given myself enough room here. If not, it doesn't matter because I can actually extend the paper in any direction. Let's delete our rays and let's draw our object. I want snap to grid on now. Let's draw our object halfway between the focal point and the lens. So there's our object. Where's our image going to form? Let's do the same thing we've been doing the whole time. Let's draw a ray. Do you remember that ray, the first principal ray, parallel to the principal axis through the far focal point? Rules haven't changed. You're about to see something pretty confusing if you've not studied lenses before. But when you do study lenses in your school or wherever you're studying them, and your teacher says to you what happens next, you'll be able to amaze your friends by knowing the right answer. Okay, so where's the second principal ray? Well, the second principal ray goes straight through the centre of the lens undeflected. And you draw that principal ray, and then you start scratching your head and thinking to yourself, oh no, I must have made a mistake. Or, oh no, Keith got it wrong. It was obviously wrong, because look, the rays don't cross. The rays don't cross. So where's the image? Maybe there is no image, or something like that. No, let's just calm down a second. Let's have a look at this. Remember what I said about what an image was? It's where the light appears to be coming from. So if this is my observer, sat here looking at this, remember, my primitive brain doesn't know there's a lens there, and it's going to see these rays diverging from some point earlier on. Up here somewhere, there's some point from which the rays are diverging. So let us extend these principal rays back. We're going to draw what we call construction lines. And so I'm going to use a different colour. I'm going to use grey for this, a very light grey. And if we extend those rays back to see where the brain thinks they came from, this one is somewhere back here, but we don't quite know where. Let's just extend it right the way back to up here somewhere. So somewhere along that line is where that first principal ray appears to have come from. Let's draw the next one. Somewhere, and you know, it's always good to be using a ruler for this, somewhere all the way back here is where the second principal, snap to grid, is where the second principal ray appears to have come from. So if you look at the diagram, you can see what I mean. Those grey bits aren't actually where light, these grey bits aren't actually where light is, but it looks like there is. In fact, what I'm going to do is I'm going to make these lines. Why that's not working, make these lines dotted lines, because that's what we would usually do. We'd do dotted lines for construction lines, and we would do solid lines for rays. So let's do these as dotted lines. Okay, there we go. So somewhere between back here is where the primitive brain thinks that the object is. That's the image. What about the third principal ray? Well, let's draw the third principal ray. Let's use the instructions just as they were and we'll see the problem. The instruction I said was go through the near focal point. But if I go this way, I'm going away from the lens. Oh dear. But what I could say is that a ray that passes through the object and through the near focal point will then refract parallel to the principal axis. It doesn't actually matter which direction it goes through the focal point and the object. So if I draw my ray going in the other direction up here, such that that ray is in line with the focal point, what I hope you can see is that a ray passing from this focal point through the object, hitting the lens, and then going parallel to the principal axis, is following those rules. These two are in the different order, but it doesn't matter. We're still following the same rules. We're still going through the near focal point, through the object, and then parallel to the principal axis. And again, this is a construction line, so we can make this a dotted line. It's just there to help us draw our diagram. This is a straight line passing through the focal point and the object. Then this ray is going to refract parallel to the principal axis, which is over here. And you look at that and you think, I don't know what's going on. Where on earth is the image? I've got these three rays. But again, remember what an image is. It's where the rays appear to diverge from. We've got these three rays, this one, and this one, which all appear to be emanating from some point earlier on. That point earlier on is the same point for all three rays. If I extend this ray back to where the primitive brain thinks it originated some point along here. Again, let's make this a dotted line because it's a construction line to help us with the diagram. It's not actually where light is going. And what do we see? We see that there is, about here in this case, an image. Now, does the light actually pass through that image? That point at the top, does the light actually pass through there? No. If I were to put a screen there, it wouldn't make a difference. I wouldn't be able to see it because the light is being refracted and diverging out like this. So that is a virtual image. The light isn't actually coming from there, it just looks like it is. You'll notice the image is magnified, it's larger than the object. In fact, in this case, because of where I chose to put the object, I chose to put it at half the focal length, and so the image is twice the size of the object, so it's a magnification of 2. But because this is upright, not inverted, the magnification is -2. It's -2 magnification. That's not on GCSE specification, so don't worry too much about whether it's positive or negative magnification at this stage. Let's just delete some of this highlighting. Let's put my stroke eraser. Come on. It's deleting lines. Come on, Microsoft, you can do better than this. I'll leave it like that. So, let's answer those questions. Where is the image? It is to the left, isn't it, on this picture? To the left of the object, to the left of the lens. So, what have we got? At 2F on the right, no, that's wrong. At F on the right, no, that's wrong. Between F and 2F on the right, no, that's wrong. On the right, no. More than F to the left of the lens. Less than F to the left of the lens. Well, because of where I chose to put it, is exactly on F to the left of the lens. Who designed this question? It could be either of them. It's neither of them. Which one should we pick? Should we pick that one? Correct. What would happen if I pick less than it? Incorrect. Okay. I think I might have to look at this question again. Right, what is the size of the image? It is enlarged, it is upright, and it is virtual. And that's it. So Lexa said, thank you for that question. Thank you for that. The question now makes a lot more sense. Good. Glad it does. That was that's the whole reason why I do this. There we are. I'm feeling better now. I was all moody early on this morning, but I'm feeling much better now. Thank you. Thank you for cheering me up. So that's lenses. Lenses are tricky. There's a few reasons why they're tricky. Firstly, because they're relatively new, and so teachers are still not so experienced teaching them if they haven't taught IGCSE, well, Cambridge IGCSE before. And secondly, they are tricky, but there are only a few rules. And if you want some help, some practice with lenses, I've got a drill sheet that you can use. So I'll just load it up to show you. And if you send me a message on Facebook Messenger or something, I'm happy to send this through to you. Let's just go to Physics with Keith, Electronic Resources. Here we go. So I've got a bank, I think I would call it, a bank of resources that I've made that I'm always happy to share. Electronic resources, and here's a few of them here. This in here somewhere you'll find GCSE lenses drill. Load it up. All my resources are spreadsheets. Most of them, sorry, are spreadsheets. And I've deliberately made them compatible as much as possible with Microsoft Excel, so that you can use them with other systems as well. They do work with even my Android phone running something called WPS, is an office piece of office software. So they do work with all these different packages. Let's auto hide the ribbon. Oh, it maximizes it when I do that. Of course it does. Right, get rid of that. Oh, no, that'll do. Right, so the way this question generator works is it gives you a question, gives you some questions at the bottom. Locate the image on the diagram above. What's the image height? What's the magnification? Then you click answers, and it will show you, let's just zoom out, it will show you the first principal ray, the second principal ray, the third principal ray, if it's possible to draw one, and then the position of the image. And if there is no image, it just says error, no image. And if I go to, there's two different modes on this. There is the random mode where it just generates questions. So that means debug mode is off. And what you'll do is you'll just press F9 and it'll give you a different question. F9 will give you a different question. And so this one, for example, is a concave lens. You'll see the symbol is slightly different. The object is here. You have to count across the squares to work out where the object is, the height of the object. You've got the 2 focal points there. And then you'll draw your diagram on a separate piece of paper. I wouldn't bother printing this one out. I would get a separate piece of paper, a graph paper. I draw my diagram to scale. You draw your principal rays. It says there's the first principal ray, and this is a concave lens, remember. So the first principal ray goes parallel to the principal axis, then away from the near focal point. The second principal ray goes straight through the middle undeflected, and the third one goes towards the far focal point and then parallel to the principal axis. And then when you combine the 3 rays, it produces an image here. And you get the information there, although that magnification there should show a minus sign, so there's a problem with the calculation. So that's the first mode, which is random mode, and it just generates random questions for you to try and gives you the answers. The second mode, if you go into debug mode, you can actually choose where you want to put things. So you can choose a concave or a convex lens, you can choose the object distance, focal length, and object height, and then it will choose where the image is. There's a little bit of a cheats way of doing it, really, because you see the answer when you already start. But if you've got a particular question you're not sure of and the random thing just isn't bringing it up and you want to try out a particular geometry, you can throw it at the debug mode. Actually, I made debug mode mainly for teachers so we could set our own questions. So that's available for you. Just let me know if you want a copy of it. Right, are there any other questions you want me to go through, or shall I get recording week 5, I think it is. Shall I get recording week 5? Let me know if there's any more questions you want to go through. Week 5 is on nuclear physics. No messages coming through saying they want to go through anymore. So I guess that's that. Thank you very much for tuning in. I hope it's been useful. I will. I'll stop there. I'll record the video for next week. It should be up today, and I will set the Isaac Physics board. And do try to do it, because really the only one who benefits by doing it is you. This doesn't benefit me at all. I'm not getting paid for this. I don't get any money for this. You don't get any YouTube money, contrary to what some people think, because I don't have anywhere near enough subscribers. But tell your friends about this, get them involved, because it's going to help everyone. We want more physicists in the world. I'm going to stop there. Right. Have a good weekend, have a good week, stay safe, and I will see you next week.